Okay, hello, my name is Alex Ham. This is for discrete mathematics review for exam 2, going over induction and probability. So here I have 1, 2, 3, 4 questions from induction, proving, and then this is from probability. So this is question 14 on the probability little, not playlist, but the section, and then this is question 1, 2, 3, and 4. These are the first 4 from the induction section of problems. So I'm going to start here on question 1. So before we even begin, we want to test our base. Here we have a summation of numbers, so we're saying plus n. We're trying to show that this equals n times n plus 1 over 2 for all n greater than or equal to 1. So what we're going to do, we're going to test our base, which is basically this right here. So we're going to say that the lowest n can be is 1, right? It could be either greater than or equal to 1. So we're going to put 1 in, substitute that in for n. So we're going to have 1 equals 1 plus 1 over 2. And then we know that this is going to be 1 times a 1 plus 1. This is going to be 2. 1 equals 2 over 2, which is 1 equals 1. So that checks. Next, what we want to do is we're going to assume this is true for n equals k. When we do that, we're going to have 1 plus 2, this little summation of numbers here, plus k, right? So we're saying that n equals k, so we're going to substitute k in for n. That looks bad. K equals k plus 1. Again, we're just replacing the n over 2. So we're just going to assume this is true, and then now we want to show for n equals k plus 1. So when we do that, I'll go down here. We're going to have this, again, this summation of numbers, right? Plus k, but now we want to show for k plus 1 equals, and then we're going to substitute n, so we're going to have k plus 1. We're going to have k plus 1 over 2. So this is going to be, we can simplify this a little bit, and then this would be k plus 2 all over 2, right? And then what we're going to do here, so we assume this is true for this. So what we're trying to do when we show, when we get to our showing section, we want to show true for k plus 1. We want to use what we already know is true. We said that this is true up here. So we know that this guy right here is equal to k times k plus 1 all over 2. We're going to substitute that in right here for this guy. So we have k times k plus 1 over 2, and then we have this guy right here, remember, plus k plus 1. And then our goal is to just basically show that this equals to this. So what can we do? We can try to put this together, right? So we'll have k plus 1 over 2 plus 2k, oh gosh, plus 2 over 2. Then we can put this together. So let's see, we could have, let's see, k squared plus k, oh gosh, plus, let's see, yeah, k squared plus k. This looks so bad. Sorry, I know my handwriting is not good. Plus 2, this is going to be all over 2, right? And then we can combine this again, simplify a little bit more. 3k plus 2 all over 2. Again, this is still equaling this. I'm just not writing this down. Sorry if you can't see. And then we can factor this, right? So this is going to be whatever adds to 3 multiplies to be 2. So that's 2 and 1. And then we have shown that this is equal to this guy over here. So I can just write that down. K plus 1. And then once we've done that, we're pretty much done. These two are equal. Check. Going over here, we have pretty much same thing, really. Again, we're going to try for our base. We have another summation of numbers plus n squared. So the lowest n can be is 1. 1 squared equals 1. 1 plus 1. Gosh. Let's see here. Let's see if I can do this. Okay. 2, 1 plus 1 all over 6. Okay, what do we have here? Let's see. So we have 1 equals, oh wait, what is this? This is supposed to be a 1, isn't it? So this is going to be 2, and then 1 times, let's see, and this is 2, 1, so, okay, yeah, so then we have 2 times 3 over 6. This is equal to 1 equals 6 over 6, which 6 over 6 is 1. We know this is true. And then now we're going to assume that this is true for n equals k, just like we did before. We're going to plug everything in. We have, you don't have to write this down every time. I don't know why. I just like to. Squared plus dot dot dot. We're going to have k squared now, right? Equals k. Again, just plugging k everywhere. Plugging k in everywhere for n. 2k plus 1. This is all over 6, right? Okay, again, just like last time, now we want to show that this is true for n equals k plus 1. Let's see, I'm gonna go down here. Again, we have this guy, right? Plus dot dot dot, we'll have our k squared. Now we want to show for k plus 1. And then this is going to be, okay, so this might get a little messy. This is k plus 1. Oh my gosh. Parentheses plus 1, and then we have 2k plus 1, parentheses plus 1, parentheses. We can go ahead and simplify this guy a little bit. So we can just keep this k plus 1. This guy's going to be k plus 2, right? And then this is going to be a 2k plus, so this would be 2k plus 2 plus 1 plus 3, all over 6, yeah. All over 6, all over 6. Okay, come over here. Again, we know that this guy is true, so we're just going to substitute this in, right, for this guy. So we have k plus 1. Yeah, I don't know what happened there. Plus 1, 2k, oh gosh, plus 1. This is so bad. All over 6. We have this guy. Can't forget about him. He's pretty important. He's going to help us. And then these two right now are equal, or not right now, but we want to simplify this somehow to get it to look like this guy, right? So what we can do, we can pull out, we notice that there's a k plus 1 in both of these things. We can pull that out. K plus 1, and this is going to leave us with k 2k plus 1 all over 6 plus a k plus 1 equals this guy. Now we want to try to get these guys to go together, right? So what we're going to do is multiply this guy on the right by 6, right? Numerator, denominator. Let's see, 2k plus 1 all over 6. This is going to be 6k plus 6 over 6. This is still equal to this guy over here. Oh, let me get down here. Okay, and then we have, okay, so let's try to put this together. This is going to be 2k squared, right, plus k plus 6k plus 6 all over 6. So we can go ahead and simplify it. So we have k plus 6k, so we just know that this is going to be 7k, right? And then it looks like we can factor that. So how I factor is kind of different, I think. So I'm going to use slide and divide method. Okay, so what I do is I take this 2 and I slide that over here to the 6, multiply that, and then that becomes a 12. I can factor this now. What goes into 7 and 12? 3 and 4, right? Now we're using slide and divide, so we slid. Now we have to remember how to, not how to divide, but we have to remember to divide. To do this, I'm gonna go over here. So we're gonna have, let's see, k plus 1. So we're gonna have k plus 3. So we want to divide these numbers over here by 2, the thing that we slid by. So we slid by 2, right? So it's gonna be 3 over 2. But we don't want a fraction, so what we do is we take that 2 in the denominator and we put that in front of the k here. So we're gonna have 2k plus 3. And then we're gonna have k plus 4, 4 divided by 2. That's just gonna be 2, right? So we don't have to put that in front of the k because that actually simplifies. This is all over 6. So now what we have is k plus 1 times 2k plus 3 times k plus 2 all over 6. And that's exactly what we have over here. K plus 1 times 2k plus 3 times k plus 2 all over 6. We have shown that this is true. These two are equal. If I were to draw that down there. Okay, moving on to number 3. Okay, so this one looks a little different, but that's okay. Again, we have for n is greater than or equal to 0 this time, so we're going to plug in 0 for our base just to make sure that this is can even work out, right? So we have 0 plus this. Yes, we know that anything to the power of 0 is 1. This is equal to 1. Okay, so this checks. And now again, just like last time, I'm just going to say that this is true for n equals k. Plug it in. 2 to the k less or greater than or equal to k plus 1. And then we want to show true for, for n equals k plus 1. This is going to look like, I'll write it down here. So what do we have? Okay, 2k plus 1 greater than or equal to k plus 1 plus 1. So we know that this is going to look like this, right? K plus 2. We can combine the 2's. Okay. So we have this. What we're going to do, we're going to leave this for now. We're going to go back to what we know. We want to use what we know is true, right? And we said that this is true. So let's copy this thing back down here. We have 2k is greater than or equal to k plus 1. So now what we want to do is we want this guy to, get him to look like what we want to show is true. So right away I look at this left side and I see that this is 2k plus 1, this is 2k. So I know that I can easily just multiply both sides of this one, right, by 2. Let's see, this is going to be k plus 1. And then this is going to be the same thing as this, right? And this is 2k plus 2. Okay, well, this is good because now these guys match. So that's good. Now what we want to do is we want to compare whatever is on the right side. So we know that we want to show that 2k plus 1, or 2 to the k plus 1 is greater than or equal to k plus 1. And right now we have 2 to the k plus 1 is greater than or equal to 2k plus 2. So what we can do is do this, greater than or equal to this guy, right? We want to compare these guys. If we can show that this is true, then we'll be golden. So what we can do is subtract a k, right? This is kind of like an equal sign. Subtract a k over here, so we're going to have k plus 2 is greater than or equal to 2. And we know that this is true because before we said that, right? Oops, wrong way. K has to be greater than or equal to 0. Well, if I plug in 0 here for k, this is 2 greater than or equal to 2, which is true. And then if k is anything greater than 0, well, it's still going to be true because it's greater than. So we have proven if this is true, then this is true, then this is true. And that's question number 3. 4 is not too far off. It's pretty similar. Not too bad. Again, we're going to check for our base, right? This time we have a factorial involved. So we have for all n is greater than or equal to 1. So we're going to plug that in. Let's see. We have minus 1. We know that anything 1 factorial is just this. And then 2 to the 0. Anything to the 0 is always 1. 1 is greater than or equal to 1. So that's fine. Again, true for n equals k, right? What does that look like? That looks like k squared is greater than or equal to 2k minus 1. Okay, and then we want to show that this is true for k plus 1. This is k, that looks like a c. Sorry, it's parentheses. 2, and then if we have a k plus 1 minus 1, so that's just 2 to the k, right? I'm just gonna go ahead and simplify that. Okay, so again, we want to use it. Well, we want to show this, but we can't really go much further than this. So what we want to do is use what we already know is true. Well, we said that this is true, right? So again, we're gonna bring this guy down, use him to the k minus 1. So how can I get this guy to look like that? Well, I know that this, I can multiply both sides by k plus 1, right? 2k minus 1, k plus 1. And I know that this is equal to this. So then I can simplify this. This can just be k plus 1 factorial, right? Because k factorial times k plus 1 is the same as this. And then this guy got multiplied by k plus 1. So now these two guys look similar. So now again, I just want to compare what's over on the right side. If I can say that this is greater than, or yeah, yes, if I can say that this is greater than that, then we'll be golden. Okay, so we'll have 2 minus k plus 1, right, is greater than or equal to this guy now. Okay, look at this. I see that I have a lot over here, so I could probably get rid of something. So what I can do is I can divide 2k minus 1 by both sides, right? It's going to cancel. Oh gosh, it's going to cancel on the left side. We're going to be left with k plus 1. And this is just like 2 to the k minus 1, right? So this is going to be k minus k, which is 0, plus 1. 2 to the 1 is just 2. We have k plus 1, 2. We know that this is true because before we said for all n, or in this case, k, has to be greater than or equal to 1. The lowest it can be is 1, right? So if I plug in 1 for k, 1 plus 1 is equal to 2. And if k is anything greater than 1, then, well, it'll be greater than 2. So this is true. So that's everything for induction. That's the proving. I have one from the probability. This is going to be using the binomial, I believe this is called. The binomial theorem. I have that written up there, so this is going to be good to know. I recommend trying to memorize that guy. So this wants us to find the coefficient of x cubed in the expansion of 1 plus, oh gosh, 1 plus x to the 5th. Okay, so we see this guy, and this looks pretty similar to this, right? So we can go ahead and try to match this up. Our 1 is going to be our a, our x is going to be our b, our n is going to be 5. We know that this is equal to the summation from k equals, starting at 0, to n. Our n is 5, right? And this is going to be n over k. Our n is 5. K starts at 0, right? So 5 pick 0. Our a is 1. N minus k, 5 minus 0, times b to the k. Our b is x, remember? K is what? 0. And then basically what we can do is we can just keep doing this. So we can do it for the next one. This is going to be still a 5. Now we're going to check for k equals 1. So 5 pick 1, 1, 5 minus, let's see, yeah, right, 5 minus, yes, okay, and times k, now our times b, sorry, times b to the k, now that our k is 1. And then it says we want to find the coefficient of x cubed, right? So right here we have x to the 0, that's just going to be 1. X to the 1, that's going to be 1. Here will be x squared, and then we'll have to go one more time to get x cubed, right? So let's do this. 1, 5 minus 2 times x to the k, which is 2. We're going to do this one more time. We could keep going all the way to 5, but I'm just going to stop at cubed because that's just what we're trying to look for. K equals 3, 5, 3. Yes, and then 5 minus 3, x to the k, which is cubed now. And then I can try to make this look a little bit nicer. We can go over here and, so 5 pick 0, what is that? So that's 5. Let's just go ahead and do that, right? 5 factorial, 0 factorial, 5 minus 0 factorial. This is 5 factorial. This is just easier to cancel, right? We have 1. So we know the coefficient for the first term, x to the 0, is going to be 1. Now we can do this for the next one. 5 pick 1. 5 minus 1. This is 5 factorial. 1 factorial is 1. Right here we're going to have 4 factorial, right? We could change this into, let's see. We can change this into this times just 5, right? This 4 factorial is going to cancel. We're going to be left with 5. So we know that the coefficient for our second term is 5. And then we're just going to keep going. So now 5 pick 2. 2, 5 minus 2 factorial equals 5 factorial, 2, 3, oh gosh. Sorry, it's getting a little sloppy. 5 minus 2 is 3, right? And then 3 factorial. We can cancel out the 3 factorial if I still have 4 times this. Right, because this could be like 3 factorial times 4 times 5. 3 factorials both cancel, top and bottom. 4 times 5 is 20, and then 2 factorial is just 2, so 20 divided by 2 is 10. And then we just have one more to do. 5 factorial over 3 factorial, 5 minus 3. We can recognize this is going to be the exact same as what we just did, right? 3 factorial, 2 factorial. 3 factorials will cancel just like last time. 4 times 5 over 2 factorial. This is, again, 10. So we know that the coefficient for our fourth term here, right? This is the first one, second, third, fourth, is going to be 10. So what we can do is we can say that, let's see, 1 plus, 1 plus x to the 5th, I'm just copying this down pretty much, is equal to the summation of 1 plus 5x plus 10x cubed plus 10x, or squared, sorry, 10x squared plus 10x cubed. And we know that that's what we're looking for. So there you go. And then we could keep going all the way to 5, right? Because our n equaled 5 from the question. But it just has to find the coefficient of the fourth term, the x to the third. So, and that's pretty much it. I hope this was helpful. Thank you for watching.